Hello, students. Now, because last week, not many students attended the extra lesson. So I'm not sure that all of you are ready to move on. I actually thought to myself, oh, should we continue or should we actually conduct a revision section? But I think we should move on. I think it should move on. It's completely normal that if you need more time, or you may need to watch the video from last week more than once. But since this lesson, we have something new added. In this section, we have something new added, but we're going to use the same concept from before. So in a way, it's kind of like it's a new thing added, but still with revision on the previous concept. So I think it's right to move on. As to the homework assigned, last week I assigned some level 1 question, and this week I will assign some level 2 questions. So we will see. We will see. And since next week Saturday we have Parents' Day, so maybe I think we can cancel next week extra lesson. So you will do homework and try to catch on. So that's why I think today we should move on. Let me see how many students attending today's lesson. Now, today we have 12. That's more than last time. I completely understand. I think some students really need time to catch up. This part of integration, I say something new added is because we're going to learn some new functions. The integration of trigonometric functions. These are new. But the technique, later on you will see we use, they are similar. Now, the fundamental, the 3 formulas we learn. It's cosine, sine, and secant squared. Now, because the differentiation, there are 3 formulas. That is sine equal cosine. And therefore, you can reverse it. Now, reverse it, you get integral of cosine is sine. And we have cosine that means therefore you have this formula. And the last one. The last one is from this formula. E tangent x is secant square x. And then you have the integral. This is from our understanding that the indefinite integrals are just the reverse operation of differentiation. Then when you do it backwards, that's it. In the test on Wednesday, some students don't even know this. It's quite ridiculous. It really is. As a math teacher, I think if you don't know or you remember or you forget, the differentiation of tangent is a huge problem. You should always remember that. Try to remember that. Now, examples from the easiest ones. This one, copy 7 sine x minus 3 cosine x divided by 5 dx equal 7 sine x dx minus 3 over 5 cosine x dx, and that is 7 negative cosine minus 3 over 5 sine x plus c. And then to simplify, sine x plus c. The second question, copy the question. And then also take out 2 secant square x dx. And then take out 3, change 1 over secant to cosine. And then you have 2 tangent x minus 3 sine x plus c. The last one, copy the question. Tangent x squared plus secant x squared dx equal. For this one, we need to change tangent to secant. So I have secant x squared minus 1 plus secant x squared close bracket dx. Now this formula is also used in the test earlier this week. Tangent x squared equals secant squared minus 1. It's also very basic and very often used. Now tangent and secant work together very well. Did I mention that? I think so. So I have 2 secant x squared dx minus 1 dx, 2 tangent x minus x plus c. Is that okay? Now you can do the classwork. Now I don't know how I can check it very efficiently, but you will just tell me then. You just raise your hand. Show me by raise of hands. And maybe I will ask some of you to tell the whole class the answer. Okay, it's weird that some of you take much longer than the other ones. I suppose you have no way to show me, maybe you have done it, but no way to show me. The answers are 4 sine x plus 7x plus c, negative 1 over 3 cosine x plus 5 tangent x plus c, 8 tangent x plus c, and 2x plus 3 tangent x plus c. Let me know if your answer is different. Okay, I think it's fine. It's just in order to use the basic integration formula, as long as you have the correct function. The only function you can have is cosine, sine, and secant square. Otherwise, you cannot do it directly. You have to change it some way. Second example. This one I'm not even sure I can, but I'll try. Cosine 2x in my mind, it should be changed to 2 cosine x squared minus 1. That's a use of double angle formula. And something that you're not very good at. Because I don't know, you don't choose the correct one to use. Like in this question, I want to reduce the angle. And when I reduce the angle, I choose the cosine one, not the mixture and not the sine one. You always know your intention. And then this will be 2 minus 1 over cosine x. And that is 2 minus secant. Now usually you should put a bracket, but it's fine if you don't. And that is 2x minus tangent x plus c. I think in this example, it's just more trigonometric identities are used. In this one as well. This one, in order to increase the angle, I also have to use double angle formula, but backwards. Now to use double angle formula backwards, I will have 1 minus cosine x divided by 2. This is again something that you're not very familiar with. Here I need to revise with you the double angle formula, the 3 forms, and the opposite, the reverse ones, 2 of the reverse ones. Let me write them down. Cosine 2x equal co minus sine also equal 2 co minus 1 also equal 1 minus 2 sine squared. In part A, I use the second one. Double angle formula. But the reverse one is the opposite one. That is sine x squared equal 1 minus cosine double angle divided by 2. And also cosine squared equal 1 plus cosine 2x divided by 2. And in part B, I'm using this one. To get this one, you need to just relate this one. These are the same. I'm not going to detail. I just need to tell you, oh, this is this one. You change the angle, you reduce the angle, whereas this one, you increase the angle. They're the same formula. It's just different position where I put the sine square. In the previous one is sine square on the right-hand side, and this one is sine square on the left-hand side. That's a very common use. Very, very common use. So if I carry on, it's 1 over 2, 1 minus cosine x dx, and that is 1 over 2 x minus sine x, close bracket, plus c. And then you're done. Can you try the classwork? If you need help, just refer to these formulas. Let me know when you're done. Okay. This time quicker. Again, double angle formula is used. The first one, the answer is negative 2 cosine x plus c. The second one, the double angle formula, more difficult. You have to use this one to increase the angle and reduce the power. Now, I remember last year you did very well with the identities of trigonometric ratio. You need to remember what you've done. You need to remember, and also remember the functions of each identity. What do they do? So this one is to increase the angle. To increase the angle. Moving on. Let's move on. Now, starting from this example, you will see that the integration formula, I mean the trigonometric ones, cannot be applied immediately because the function is changed. The function changed. And you will see me using the technique of substitution. That is integration by substitution a lot. So it's like a revision, For this one, let me change the color. sine 3x plus 2 dx. Now, because we know a formula that's integration sine equal cosine, negative cosine, but that cannot be applied immediately. It cannot be, because they're not exactly the same. Because here you have 3x plus 2 and here you have x. That's not the same. It's weird that in the integration, this kind of algebra, that a slight change in the function, it changed everything completely. That means the result is not negative cosine. It's something else. Something else. So bear with me. In order to use the basic formula, what you need to do is to change. You just need to change dx. Sorry, made a mistake. You need to change dx. And how do you change dx? You change it to d3x plus 2. That this is the integration by substitution. It looks like you're multiplying 3 and divided by 3. Fine. If you think that, that's fine. But it's not in the concept is not entirely that. Last time I explained. This time we just move on. And then I take out 1 over 3. And then it becomes integration sine u du. And that is negative cosine u. Okay. For the second one, it's cosine squared. I know we have integration of cosine equals sine, but that cannot be used directly. Let me write it down. We have this formula. Integration of cosine equal sine plus c. Now, do you think if I add a square here, I just add a square to the answer? And that's not the case. It just doesn't work with integration. Integration is the most weird algebra. In the algebra you learned before, a lot of times things can be replaced, and there's been substitution, and then you change down, they're still equal. Like identity, right? If you change the angle, they're still equal. But this thing is so it's so fragile. I think it's very easy to break. You change anything, like you add 3 and then you add a square, it doesn't apply anymore. And you have to find a way out, and it's not an easy way out usually. And this one, in order to use the formula, you must completely forget about this. Completely forget about this. You must change this and increase the angle and reduce the degree. Now here again, I'm applying the double angle formula in the reverse way. This is the third time today. You see, I increase the angle, but I reduce the power. Now here I'm focusing on the reducing of the power because that's more useful. To me, it's more useful. It's 1 over 2, 1 plus cosine 2x dx. Okay. Okay. And then I think we have a chance because now it's cosine 2x, and I only have to change dx to d2x. So here you see me, 1 plus cosine 2x, 1 over 2 d2x. Because I need to change the variable. Okay, now bear with me. It's 1 over 2. It's 1 d2x plus cosine 2x d2x. Oh, it's what? 1 over 4, sorry. It's 1 over 4. Because I take out 1 over 2 d2x. And then it becomes 1 over 4, 2x plus sine 2x and plus c. Is it fine? Tell me if you have any question, because it can be quite confusing. Now, in the end, we did use this formula, but that's quite towards the end, not at the beginning, definitely not at the beginning. Towards the end, I still use the formula, you see here. But that is even, I think it's in integration cosine u du when I use it. It definitely without a square. Now, usually from the textbook, I only show you 2 examples, but because of the complexity of these questions, I'll show you double the amount. So you have example 4b. Actually, I think I should have more. I don't know why. I think two of this are missing. Are they? Anyway, now I think another set should suffice. This one, another set of example of the same kind. Cosine x plus 1 dx. Change it to cosine x plus 1 dx plus 1. Although it's just plus 1, actually, that's a change of variable. It's a change of variable. Substitution. And then it's negative sine. Oh, it's not negative sine, sine. It's sine u plus c. Next one. Sine 4x minus 3 dx equal sine 4x minus 3, 1 over 4 d4x minus 3. That is 1 over 4 sine u du. And that is 1 over 4 negative cosine u plus c. It's small, but there's a substitution. Next one. It's a similar one with a cosine, or with a square, with a square. This one, it's cosine square. And first, I need to take out, let's not take out, 1 plus cosine, increase the angle, but reduce the power. So maybe I write it here. Okay. What did I do? Sorry. I'm just gonna put it here. Okay. And then I will take out 1 over 2. And then I'm left with 1 plus cosine 6x. And here I'm also changing dx to d6x. That's 1 over 6 d6x. And then I'm getting 1 over 12. 1 plus cosine 6x d6x. And then I should have 1 over 12 6x plus sine 6x close bracket plus c. Let me know if you're confused, huh? Because you may not think the same way. Last one before the classwork. Tangent square. First, you will change it to secant square minus 1. Okay. And then what you do is you will change the variable. One over 66x dx. 1 over 6x dx. 1 over 6 d6x. And then you will take out 1 over 6. Remember that here it's secant u square minus 1 du. Secant u square minus 1 du. And then it's 1 over 6. Tangent u minus u plus c. Is that okay? If you have no problem, you can work on the classwork and let me know when you're done. Okay, Emily, you must really work faster. Okay. Let's look at the answer. My girls, I recommend you that you don't write less steps than I do. Now you can see that in the classwork, I write way less steps than the example, but that is the limit. Please don't try to get it to the too fast, because this thing, it's not easy to get it right. Now you can take out 1 over 5 immediately, I think. The answer is negative 1 over 5 cosine 5x plus c. The second answer is negative 1 over 2 sine bracket 1 minus 2x plus c. The next one is 1 over 4 tangent. There's no square. The secant has a square inside, but here outside tangent doesn't have a square. It's 1 over 4 tangent bracket 4x plus 3 plus c. Last one, the double angle formula is used. You can take out 1 over 2 directly. You can do that immediately. In the next step, you can take out 1 over 4. Okay, the final answer is 1 over 4 bracket 2x minus sine 2x close bracket plus c. You can also have your answer expanded. It's fine. Okay, so I think here we're doing integration by substitution. In a way, we're revising the things we learned a week ago, like a month ago, 2 weeks ago, 1 week ago, and a month ago before the Chinese New Year holiday. Next one, still about substitution, but on another level. On another level. So this one, I prepared 2 sets of examples. Because in the textbook, you only have one. 15. X cosine x squared dx. First, my step is to switch the order. Okay, prepare for x dx to be changed to something else. Then here I'm changing cosine x squared. This one is changed to 1 over 2 dx squared. Again, this is the difficult part. If that's the case, think about if that's the case. If you need rough work, that's fine. We're gonna do the rough work again. That is the rough work is dx squared dx equal to x. Therefore, dx squared equal to x dx. Therefore, 1 over 2 dx squared equal x dx. If you need this, that's fine. That's fine. But in your mind, I think that last time we mentioned that x can be put in to become x squared, whereas x squared can become x cubed. X cubed can become x to the power 4, and so forth. In a way, if you want to do a substitution, and then that's how it works. Okay, then that's the substitution. You figure out a way to accept it. Figure out a way to accept it. What does this look to you? To me, it looks like I am doing integration. It's better if you think that you're doing integration than differentiation, because if you're doing differentiation, then it's backwards. But if you're doing integration, it's like to integrate x. Really, this means to integrate x. Now, what is to integrate x? That means 1 over 2 x squared. You know? Okay. And then we can take out 1 over 2 cosine u du, and then it becomes sine u. That's why I said this is another level. It's not just a constant. It's a variable. It's a variable. This one. 2 cosine x, 3 plus sine x squared dx. Again, I'm going to put maybe 2 outside. I think it's easier that way. And here I will put cosine x dx together. Now, remember, I'm not changing anything. I'm just taking out the constant, and then I'm putting cosine x next to dx. Just to separate this fraction, basically. And then there is a substitution you need to do. That's 3 plus sine x whole squared. And this one is d sine x. This one is new. It's new. We've never done this before. Cosine dx is d sine x. It's like integration cosine and sine. Or you can say, now, this one is to integration cosine and sine. Sorry. This one is to integration cosine and sine. And this way it's to differentiate cosine, sine is cosine. You can think it this way and this way. Anyway, and then I need more. I need more. This is 3 plus sine x to the power negative 2, but here I also need to change it to 3 plus sine x. That's another substitution. This time I'm adding 3, so nothing should be adjusted. Just adding 3 is fine. And then I can use the power rule again. I don't know if you still remember power rule. This is 2 times negative 1, 3 plus sine x to the power of negative 1 plus c. In the end, it's negative 2 divided by 3 plus sine x. No bracket is needed. Plus c. Okay. Now this one, x dx, is something that we worked on last week. I hope you still remember today. For part B is a new one. Part B is a new it's new. It's the same concept, but a different function. I'll show you more. Show you more. Since this is new, I show you more. Another set of examples of the same kind. This one. Copy the question. Secant square x cubed minus 4 dx. I think for beginners, I try to adjust the order. I put x squared next to dx. But when you are more familiar on this topic, then you don't have to really do the switching the order. Anyway, this one will become 1 over 3 dx cubed. Now, even though you don't see it in the past, I think you should see it today, that how this works, right? How does xn become xn plus 1? And then I take out 1 over 3 and secant square x cubed minus 4. And then also another change because I need that x cubed minus 4. Then here I'm adding minus 4. And this time you don't have to do any adjustment. And then it's tangent x cubed minus 4 plus c. Last example. Sine 2x 4 minus cosine 2x dx. This one, 4 minus cosine 2x sine 2x dx. Okay. Now the first thing I do is to change x to 2x. But to do that, I will add a 1 over 2. That's the first thing to do. Okay, that's the first thing to do. Change x to 2x. Now you need to do that, otherwise it's not correct. Okay. The second step is to change this to d cosine, but add a negative 1. Add a negative 1. This is another one. Let me use another color. It's negative 1 d cosine sine. That means to integrate sine, that's negative cosine. Okay, that way, that way. I know it's confusing. I really understand. When I started to learn this, it was also confusing to me, but I did a lot of exercise. So this is negative 1 over 2, and then 4 minus cosine 2x, and this one I'm changing to 4 minus cosine 2x. Another substitution, and this time I need to change it to positive. Do you see? It's a positive now. Okay, in the end, it's 1 over 2 log 4 minus cosine 2x absolute value plus c. Okay. And this should be the answer, but if you want to go further, you can also remove the absolute value sign, because in this case, 4 minus cosine 2x is definitely positive. You can only remove it when you know that the function you're writing inside the log is a positive function. Now, since we know cosine is definitely smaller than 4, therefore, the absolute value sign is not needed. You can remove it. But it's not the case with some other function. Some other function may be positive. We don't know whether or not it's positive or negative. I hope that's okay. Let me know if you have any question. Let me know. Let me know. Sorry. Is it fine? Sophie, are you okay with the process? I mean, the progress?
Yes.
And Emily, you acquired the entire time?
Yeah.
Okay. You should always speak out if you are stuck. Another set of example. Oh, I think I prepared 3 sets of examples. Excessive examples today. This one of the same topic. It's the same technique, but in different questions. So for this one, to integrate ex sine ex dx equal sine ex dx again. And then this one is sine ex dex. That's my substitution. And then I'm getting negative cosine u. Let's see. It's new. It's new. But I hope you find it easy. This substitution, I hope you find it easy. Just this one. The last one. Sine x minus cosine x. Sine x plus cosine x cube dx equal 1 over sine x plus cosine x cube times sine x minus cosine x dx. Again, that's just a separation. And then I will have sine x plus cosine x cube. And this one, bear with me. It's d negative cosine x, negative sine x. Think about it. Take some time to think about this substitution. Or integration, if you may. Right now, I think it's fine to call it integration. Because it's an integration. You're doing differentiation backwards, that's integration. And Cherry, I'll go back to that question later. I will go back to your question later, Cherry. But focus on this one right now. Sine dx is negative d cosine x. This is d negative cosine x. Cosine x is d sine x. So that is the huge thing, right? And then you take out negative sign. You can take out the negative sign. Have I explained that the negative sign can be taken? I hope so. I hope so. Because you can see it as another substitution. Okay, and then you can use the power rule. -2. -2. Is that okay? No, girls, and at any point, if you find what I'm doing now, I mean what your teacher is doing now, confusing, you can try to differentiate my result. Like for example, if I take this answer, 1/2 sine x plus cosine x -2. And then I differentiate it. You will get I hope you can see that. At any point, if you think, oh, this is ridiculous, and then you can try to understand it, because you can see that if I take my answer here and do the differentiation, I will get this function, original function, you see? And that should confirm you this answer is correct. And also give you some insight as to how this can disappear. You see, at this point, this disappear again, right? This part disappeared and becomes here inside. And this is how this part is created. It comes to being in the end. You see, this cosine x minus sine x doesn't exist at the beginning. It only comes to the light in the last step when you differentiate it. And then in the integration part, it comes to being earlier than the final result. I hope you understand. I hope you understand this. That's this one. Cherry wants me to go back to a certain question before 5BB, 15BB, and explain how we change sine 2x to negative cosine 2x. Cherry wants me to explain again how this is done. Now I can explain using the differentiation, because d cosine 2x d2x. Perhaps I should use u. Is it fine? I don't want to use 2x. Let me use u. Okay. This part. Now it's d cosine u du equal negative sine u. Correct? Therefore, d cosine u equal negative sine u du. That means negative d cosine u equals sine u du. Now here you should understand u equal to x. That's how I thought about changing sine 2x d2x to d cosine 2x. It actually, this ran in my mind before I even wrote it. I know this for a fact. It cannot come to you if you don't know the differentiation very, very well. It's just the fact. If you don't even know differentiation, how do you do this backwards? Now, I already know this, so I did the substitution like that. This is my substitution. I literally changed sine u du to negative cosine, negative d cosine u. I literally did that. Let me know if you don't understand. That's why it is correct. But may I ask if the negative sign can be moved to both outside the integration symbol or inside the integration symbol? Thank you. That's a good question. That's also a good question. The negative sign can be here. It can be also outside. This negative sign can be put here. It can also be put outside. It does not matter. Let me just write it clearly. If the negative sign is here, nah, this f of x dx is equal negative f of x dx. It's also equal f of x negative dx. You can also move it inside if you want. If you may, maybe you want to do that. That's a good question, Jerry. That's a good question. Where you put the negative sign, I think the first one you may understand, inside or outside integration sign, they're equal, equal. Also this one also equal. You put it here, they're equal because you are this whole thing between the f of x and dx, you must think they're multiplying. Okay, this sign is the integration symbol. Later on, you will know that integration symbol is actually the letter S, elongated S, long S. But this one with the relation with the function inside and dx, it's actually they are multiplying. You cannot. It's not a like a net that like the most general meaning of multiplying, because it's not. It's really is not. But it can be seen as multiplying because differentiation can be seen as division. Now, you mind with me? You bear with me. Now, differentiation is delta y over delta x. Delta x. But you will send delta x to 0. That's differentiation. Differentiation is dy over dx. Dy over dx is a fraction, but not a normal fraction. It's the limit of a fraction. This one is a multiplication, but not a normal multiplication. It's the limit of multiplication. So where you put the negative sign, I think it can be anywhere. Not here, or here, or here, or here. 4 different places, all the same. Okay. I'm glad that you understand me, because not many people understand me. I can say no one understands me, maybe. As the years go by, not many people understand what I'm talking about. Anyway, can you try the classwork now? Hopefully you can succeed finding the correct answer. Let me know when you finish. You ready? Almost all finished. Except for Catherine. Catherine, you need to write faster. Okay, let's check the answer. You tell me if my answer is wrong. I need to do too many things at the same time, but I try to get them organized. For example, I need to replace this with this. And I also need to reduce the power, increase the angle. I did two things. I think it has to be done. Otherwise, it cannot be solved. It has to be done. Okay. And then I will take out 1/2 again. So you can see 1/6 here. And I also did another substitution right there. Like you don't even see it. You see, I did a substitution right there with multiplying 2 divided by 2. Because I don't need x cubed, I need 2x cubed. And then I take out 12, and then I did the final integration. I think that's the correct answer. If your answer is different from mine, maybe you need to check with me, if your answer is different from mine. Second question. In the first step, I will create the angle. I need to create the angle. Because the angle we're using now is 3x, but I now don't have 3x, that's not good. So the first thing is to create the angle. The second thing is to replace cosine u du with d sine u. That's another thing. Cosine u du, d sine u. This is similar with the previous thing we did, but this time without negative sign. Because this one, it doesn't have a negative sign, which is good. Which is good. And then adding 5. In my next step, adding 5. And then the integration. So in each question, I think it really cannot be done in one step. It really cannot be done. Now, if you are used to the subject, you must know that you must enjoy writing. If you don't enjoy writing, then it's painful for you. It's painful. I suggest that you should enjoy writing. Like you don't want it to end. Like you hope that this question is as long as possible, that you don't want it to end. Then you may feel better with these. Usually it takes very long. But I think if you're better at it, then you can reduce it. You can make it shorter, but not at the beginning. It's very intricate, everything. Do you have any question? Let me read it. Cherry said, I find this question in our textbook, but the answer is different from ours. You found the question. Which question, Cherry? Which question? A. You found it in the textbook. Let me see. Textbook. It should be in the textbook though, because I got it from the textbook. You're right, it's from the textbook. All of you should just go to your textbook and see if there is a question like that, and then see what the answer is. Oh, yes, yes, yes. I think this person is Anna. Anna, you, I think you are you. Anna told me that there isn't a square in the textbook question. Let me confirm. Let me confirm. I think we need to confirm. I don't know who is Dot. Dot is Anna, I think. You're not, it must be, because you're naughty. Textbook 15. This one. Yes, yes. You see, there is a slight difference. Maybe I copied it wrong. Maybe I meant to copy this question, but I added a square. Okay. Yes, you see, this one doesn't have a square. That's way easier if it doesn't have a square, right? And the answer is this. Yes, yes. But I think I copied wrong. But anyway, did you get the correct answer? Now this one is different then. If I add a square, it's a different thing. It's a whole new thing. Maybe I should delete it. Oh, maybe I should. Okay. That's that. That's that. That's the whole thing. I think with the integration, 3 new formulas added, and then you will use it and then to integrate some of the functions. So it's, I don't know if it's easy or not. But at this stage, I should call them easy. A few substitutions until you get the answer. In comparison to differentiation, I think this level of difficulty is equivalent to chain rule. Chain rule, but backwards. It's just so sad that not everyone can understand chain rule very well. So that with this thing backwards, this is the same level as the chain rule, maybe even more, but equivalent. In my head, it's equivalent. It takes some time for you to get used to. Now we will have 5 minutes break because the next topic is a new thing. It's a new thing. It's not I think it's not so focused on the integration part. It's more focused on the identities that you already forgot. You have a look. Now sometimes when the function is not difficult, but the angle is difficult, like you can see, there's 6x, the angle is huge, and the other angle, the angle is big, then the identities should be applied. This is more identity than integration. 5 minutes break. We'll come back in 5 minutes at 21:26. Okay, we are back. For the next few examples, they are still about trigonometric functions. But it's not like they're mixed with anything else. It's just pure trigonometric functions. So in order to integrate, find the primitive function, there are usually a few very useful techniques. The first one is product to sum. Product to sum. When you see cosine multiply sine, when you see anything multiply anything, and then that means the power is high. To my understanding, it's that the power is high. You need to reduce the power. And to reduce the power, the most efficient is to use the product to sum. Cosine sine, it's 1/2 sine 8x minus sine 4x dx. Okay, take out 1/2, you will have sine 8x dx minus sine 4x dx. Maybe you put the bracket here now. Okay, and then this is 1/2 sine 8x 1/8 d8x minus. Now here, I think it just looks better if I put 1/8 outside. And then this one is 1/4. Eh? Why do I always do that? What d8x minus 1/4 sine 4x d4x. And then it's 1/2, 1/8. This one is negative cosine 8x minus 1/4 bracket negative 1 over negative cosine 4x plus c. I think so. So in the end, it's negative 1/16 cosine 8x, and then plus 1/8 cosine 4x plus c. It does take long though. It does take long. Is that okay? Even if the even though you can use the product to sum, yes, product to sum, to reduce the power, increase the angle, that the power is reduced, and then you can integrate. Even if you successfully done that, it still takes long. Well, takes long. Anyway, I think you're fine. So you can do the classwork and tell me your answer. When you're done, let me know. Okay. Most done. Most done. Because you're reminded to use the product sum, so I don't think you can screw up. Now here I use less steps. You can see I did I didn't even show my step of substitution. I just immediately get the answer. That's fine. With these ones, I think it's okay. Okay. Shall we move on then? There's just not much to take away. It's just when you see this type, you use this particular method. It's not like, oh, this product to sum can solve so many different problems. Really, it doesn't. It can. This method can solve this problem. Okay. Next one. This one we have more power. This example we have more power. You can see that I have sine x times cosine x to the power 6. Now, if I use the product to sum formula, I have to reduce the power so badly. Maybe I have to apply it for 7 times because the power is 7 in this case. So in this case, we have to learn to be smart. This time we don't focus on reducing the power because this time we can actually make use of the power. With this type of question is different. Although you can see sine and cosine, but the solution is different. This one, you will see, obviously, you will have sine and cosine. And one of them is an even degree, and one of them is the odd degree. Now, which one is even? 6 is even. Now, this one is odd. That's to the power 1. Sine x is odd degree. This one is even degree. You will put the odd degree next to dx, and you will make a substitution. You see what I mean? You will take the odd degree, and you make a substitution. And then this thing can help you because it's actually u to the power x du. And then you can integrate using this formula. And then you're done. So sometimes with the high power thing, it's not a bad thing. It's not a bad thing. You can compare the previous one why this doesn't work. This one, because the angles are different. You can see that angles are x and 3x, and this one is 5x and x. The angles are different, but this one is the same angle. See, the same angle, different power. You can think of this. It's a new method. It's a new method. Another example I'll show you. This one again, you have sine square and cosine cube. Again, the power is one is even, the other one is odd. And you will put the odd one next to the one you want. That's the sine. And then this one will become cosine squared and then cosine x dx. Now the odd one will become an even times cosine x dx, if you know what I mean. And then it will become sine squared, cosine squared. Now it's all even outside, but this one is d sine x. There's your substitution. Okay. Now the odd power will be used and leaving you with the even power. Now you have even power outside and the odd is changed. It's changed. Now I can begin my sine x squared 1 minus sine. Then it can be sine squared minus sine to the power 4 d sine x. And in the end, it's 1 over 3 sine q, 1 over 5 sine 5 plus c. Is that okay? This one will work when the power is just works out that way. It's not like, oh, it's gonna work out every time. It's not. Usually you will have an even power and odd power. Okay, make use of the odd power. You try the classwork and let me know when you're done. Okay, please check your answer with me. I didn't write any steps. But the answer is 1 over 5 cosine to the power 5 minus 1 over 3 cosine to the power 3 plus c. The other one is 1 over 5 sine to the power 5 minus 1 over 7 sine to the power 7 plus c. If your answer is different from mine, it doesn't necessarily mean your answer is wrong. It really is not, because sometimes that answer can look very different but still equivalent. So you need to check with me if your answer is different. I think with the trigonometry is especially, not with the other functions, not so much, because other functions, if they look different, usually they're not different. Oh, sorry, what did I say? If with the other functions, if they look different, usually they are actually different. Therefore, the answer should be wrong if your answer doesn't look like the answer. But for trigonometry, you know that very weird things can equal in trigonometry. For example, secant square equal 1 plus tangent square. They don't look like they're equal, but they're equal. So in trigonometry, if your answer, the function, if your answer it looks different, it still will have a chance to be correct. Okay. That's why in your homework, I really recommend you check the answer before you hand it. Otherwise, it's creating a lot of problem for me. Unless you really don't know. You check the answer because you're old enough. Okay, that's all. Now, at the beginning, I said maybe next week we skip a week, but we still haven't finished this. So maybe next week we'll continue because I want to finish this. Yeah, because the rest of this lesson, I mean, the next week we'll just finish this material, and we will, yes, because not much new is added. If you're here today and you finish today's lesson, then maybe next week it won't be a huge problem for you. That's all. If you have a question, you can stay. Otherwise, you can leave. Bye bye. Wendy, do you have a problem?